Well, it looks like we are at our. Let's go ahead and get started and we have respect for your time as well. So we'll start up right at 11 here. Welcome. This is the OSWA webinar series, continuation with post-construction BMP options for roadway projects with John Prier from ODOT. Just a little bit about OSWA. We're dedicated to advancing the management of stormwater and related natural resources through education, leadership, watershed-based coordination, and technical assistance in Ohio. We're nonprofit and non-political. I'm Dave Reuter with Franklin Soil and Water. I'm a board member with OSWA, as well as John is too. As you can see, here's our list of board of directors. We're made up of a pretty diverse group of consultants, professionals in the field, and it's really a great group of people to get together with to really look at implementation of stormwater practices across the state. So I encourage you to join OSWA. And if you do look at the OSWA, if you're looking to re-up your membership or join, do be sure you check that box for Ohio Stormwater Association. That way you can really enjoy all the benefits that the membership has to offer. We've also got several committees within OSWA, depending on your, what your interests are. We have a new industrial section as well. And we are always looking for volunteers and members to participate in this, and it's really your chance to help, get words out, get education, and really talk to your people in the industry that do this every day. So if you want CEUs or PDHs today, be sure that you fill out the form. We need to track your participation throughout the webinar. So we'll be asking several questions throughout the webinar that you need to be able to put into this form to get those CEUs to track that. So be aware of that. That link is provided in the chat, I believe. And we'll pause and do these poll questions throughout the webinar and track that a little bit. So today's agenda is John Prier. He's an environmental hydraulic engineer with ODOT. John, I don't have your bio up. He's been around for quite a few years here. I think, what's your bio say? Here we go, 13 years. He specializes in stormwater management planning, modeling, BMPs, and permit compliance, and has experience working with facilities across the country. John works for ODOT, focusing on off-site mitigation and stormwater permit requirements, as well as coordinating with Ohio EPA. I'm going to stop my share, John, and I'm going to let you have the screen. You're muted.
All right, thank you, Dave. Let me share my screen and start the presentation, then I'll get into it in just a second. I believe I have to, you guys are seeing the notes, right?
Correct.
Let me figure out how to switch that. Give me 1 second. There we go. Now you're seeing the right thing.
There we go.
I believe. All right. So we'll get right into it. Yeah, my name's John Prier. I work at ODOT. I'm the post-construction BMP guy / MPDS permit guy. So there's a few of us at ODOT, but that's kind of what I work on. This presentation, post-construction BMP options for roadway projects, is really focused at those just pretty new to roadway post-construction BMPs or those involved in review of BMPs, maybe for a city, county, local, something. And maybe you see site development and roadway BMPs, you might be interested in why your roadway projects are a little bit different. So this project will give you the background of what some of these different roadway BMPs look like, when we use them, how we use them, and how they're different, and how some of the transportation rules are a little different from normal site development in certain circumstances for those getting a an NOI or getting coverage on the construction general permit. So if you are very familiar with post-construction BMPs, but not transportation, this will be useful. If you're familiar with roadway BMPs, then you can fill out your form to get to CDUs and then log off, because this will be mostly review, but hopefully it'll be useful. So we'll get into it here. All right, so a typical, I want to highlight the difference here between roadway projects versus a typical site construction project. So typical site construction, you know, your big box store or something is compact, one discharge point, drainage, sometimes complicated, but most time it's relatively straightforward. And you don't generally have like your neighbor draining onto you. For roadway construction, it's different because it's spread out. There's multiple different discharge points. You have limited ability to change runoff patterns because you might have something coming in that's going right back off under or across the road. There's a lot of times offsite runoff. You have narrow area to work with and limited space for BMPs. So I wanted to show real quick what a 40-acre project looks like in site development versus roadway projects, just to highlight the differences. So 40 acres on the left is a housing development with a bunch of houses and a detention pond at the bottom that drains straight into a stream. Relatively straightforward. The lowest part of the grade, all the houses drain down there and goes to the one BMP. On the right side, there's it's the same 40 acres of disturbance, but it's spread out across miles with 9 distinct stream crossings and a ton of different post-construction BMPs all over. So it's pretty big difference in your, reviewing your one detention basin for your site development versus your many linear BMPs for roadway projects. There's a lot of differences there. So that's why we should care about that. Anyway, today we're going to talk about kind of an overview of what post-construction BMPs are, the regulations. We're going to get into some details about ODOT BMPs. I'm using ODOT and transportation kind of interchangeably because most Ohio transportation agencies use ODOT BMPs. When to use them, how common they are, some good and bad things about them, and then some alternative BMP options for roadways at the end. So when we say BMPs, a lot of different people have a lot of different ideas of what that means. So what those mean. I want to break this into 3 jobs that your BMP may or may not have. One is to remove pollutants, which a lot of people think about, and I'm going to call that quality treatment. So improving the quality of the stormwater. The second one is to reduce or temporarily hold back runoff from the stream. And I'm going to call that quantity. And that's different from what a lot of cities think quantity is. You may think quantity is flood control, which I'm calling number 3. So when I say number 2, reduce or temporarily hold back runoff from the stream, I mean what Ohio EPA requires in their construction general permit, which is to slowly discharge the water quality volume or the precipitation from 0.9 inches of rain. But Ohio EPA does not require anyone to manage any of the stormwater above the 0.9 inches. So from 0.9 to your 6-inch 100-year storm or anything like that. A bunch of cities do require some kind of flood control, some post to pre-peak flow rate, or even more controlling than that. And that's to mitigate flood risk. So all of that flood risk aspect of things, which some people call quantity, some people call flood control, that's all mandated or controlled by the locals. So not at the state level, not for Ohio EPA and ODOT. So most of the BMPs, all of the BMPs I'm talking about today are quality or quality and quantity BMPs. Look at getting the TSS down, improving the quality, or holding back runoff to improve stream to decrease the potential for hydromodification. I'm not getting into peak flow control, which is that third thing. So it's important to think about kind of those 3 things when you're thinking about BMPs, because some of these ODOT BMPs do 1 or 2 of these 3 jobs that most of our post-construction BMPs might have. So BMP, you don't have to read all these. I know those words are small. BMPs have a lot of names. So these are the ODOT names on the left, a bunch of the Ohio EPA names on the right. They have a lot of different names, and BMPs can seem kind of confusing, like, oh, there's 10, 15 of them, and what do they do? How are they different? They can really be simplified a lot by thinking of it into kind of 3 basic categories. Some may not fit perfectly, but most of the BMPs fit into either some kind of detention, some kind of infiltration, some kind of bioretention, and some kind of flow through BMP, some kind of quicker flow through BMP. So if you kind of know what these four do, you kind of know what all of the BMPs do, unless you're getting super fancy, but pretty much all of them come into this, except, like rainwater reuse or any of that stuff we're not talking about. There's not too much rainwater reuse on roadway projects at this point. Not too many rain barrels next to the highway. But for those four types of BMPs, we'll call those treatment mechanisms. They to clarify what they do, because it's kind of important to think about BMPs this way. Detention kind of relies on the hydraulic residence time for things to settle out. Infiltration, the water basically just goes away. Bioretention relies on physical filtering of water through soil, through a planting media, and that occurs slowly in Ohio's world. And flow-through BMPs would be any filtering that occurs really quickly, or your hydrodynamic separation, things like that. Even your fancier filters that go quickly, we'll call those flow-through BMPs. So as your first poll question, we'll say none of these four things are flood control. So the question is, of the three jobs that we talked about before, which one are we not going to talk about today? Is it flood control? Is it quantity control? Or is it quality control? Which one? So if you answer flood, well, whatever. Answer one of those things. If it's flood control. All right, I'm going to keep going. So it's important to remember that BMPs are not that complicated in what they're actually doing. Everyone talks about like the perfect bioretention plants or phytoremediation, the soil microbes doing all kinds. That stuff happens, but in our world, it's really just, does it hold back water in detention? Does it get in the soil infiltration? Does it flow slowly through bioretention media? And when I say slowly, I mean like 1 to 4 inches per hour. Or does it go quickly, which would be anything much above 4, certainly above 10 inches per hour. So any of those high flow through things that are called bioretention cells by the vendors, and other states call them bioretention cells, but anything that flows where water goes through quickly and is held back in a big area in Ohio is not bioretention for ODOT and Ohio EPA. The locals can call your BMPs whatever you want, but that's kind of how those work. So big picture overview of post-construction BMPs. Let's get into the regs real quick. And some of this is kind of interesting in why ODOTs and transportation projects are different. So the construction general permit has this language, which I'm going to read. I don't like reading off the slides, but going to anyway. It says the construction of new roads and roadway improvement projects by public entities, which is state, counties, townships, cities, or villages, may implement post-construction BMPs in compliance with the current version, when the permit came out, of the Ohio Department of Transportation's L&D Volume 2 drainage design. That has been accepted by Ohio EPA as an alternative to the conditions of this permit. So the L&D is written into the construction general permit, okay? And technically it's the L&D at the date that the permit was issued. So whatever that date is in 2018 is that version of the L&D, which you can go find on our website, is the part that got public commented through the CGB process and has the authority of Ohio EPA permit. So ODOT's L&D Volume 2 is an alternative to Ohio EPA's Table 4A and 4B, or kind of the Rainwater Lane Development Manual, just for post-construction BMPs, not for all the rest of the conditions of the permit, but just for post-construction BMPs. That L&D material is reviewed by Ohio EPA and agreed upon. So ODOT and Ohio EPA talk about that, and Ohio EPA buys off on anything, which is important. So it's not like ODOT's off doing their own thing. Everything we do, Ohio EPA buys off on. And then as a separate function, which projects still care about, is as far as funding from the Federal Highway Administration, so the federal money that funds a lot of transportation projects, a lot of your roadway projects, it's a condition of that funding that you conform with all of ODOT's location and design manuals, which there's 3 of them, but generally including the L&D Volume 2. So that's where it gets a little interesting, because as a condition of federal funding, you need to follow the most recent version of the L&D, and as a condition of the permit, you need to follow the version of the L&D, or be compliant with the version of the L&D that was was in place at the time that the permit was issued. In general, for post-construction BMPs, it's pretty similar. When we make changes, we add options into the L&D, and it's Ohio EPA is generally on board. So that's why people care about the L&D, and that's what drives transportation roadway projects to follow the L&D. Those two rules, the CGP and the federal funding. So Ohio EPA's construction general permit is relatively straightforward and prescriptive as far as post-construction BMPs go. For small sites where the disturbance is 1 to 2 acres, you may use an alternative BMP, but the permit's written to try to say you should use a table 4A or 4B BMP unless you have a good reason. And if it's above 2 acres, you're definitely supposed to use a table 4A or 4B BMP, which are those list of BMPs: detention basin, infiltration trench, bioretention, permeable pavement, all their fun things. In ODOT's world, we have different requirements. And this is where people get hung up on a lot of the differences between transportation and site development projects. So in ODOT's world, if the project DDA, which is kind of like the land disturbance, is greater than or equal to 1 acre, generally a BMP is needed, except there's kind of 4 options. There's this routine maintenance option, this kind of straight line projects, which we'll go into. Then there's quality treatment, which is kind of like smaller treatment, and then quality and quantity treatment, which is pretty similar to Ohio EPA's table 4A and 4B practices. So I'll stop real quick for a poll question, try to get these out of the way. For the second question, in ODOT's world, if the project EDA is greater than or equal to 1 acre, how many options are there? How many of these 4 options are there? All right, so I'll give you a second to type that into your form if you're doing that. Also, the form, I mean, I know we're saying it's a requirement for CEUs. For PDHs, for engineers, I don't think it is. Like tracking the time is not necessarily important. So do what you feel, but if you're filling that out and you want to figure out how many of these 4 options there are, you can answer that. But we're going to get into these. So routine maintenance projects. So routine maintenance, all projects have the ability to do routine maintenance projects, but roadway, it's kind of evident how some things are different. So it's not the same as like, just because ODOT calls something a maintenance project doesn't make it a routine maintenance project. We can say we're doing something to maintain it. But when I say maintenance, I mean from a Ohio EPA standpoint. So that's the first thing. The disturbance has to be less than 5 acres. The permit language, which is straight from in Ohio, which is straight from some federal language, says there has to be no change to the purpose, line and grade, or hydraulic capacity of facility. And that's kind of a lot of roadway projects. Don't change the purpose, line or grade, or the hydraulic capacity. So we kind of have to limit it up to not say like all of these projects are routine maintenance, because we're not building too many brand new roads. A lot of roads are just being improved or changed somewhat. So that's going on. The other thing is all activities must be routine maintenance. You can't split up your project into half routine, half new construction. It's everything under your NOI under your permit has to be kind of the same. We have this section in L&D that lists all these routine maintenance activities. And the important thing is that if it's a routine maintenance activity as defined, it does not require an NOI, which is a notice of intent for permit coverage, and therefore doesn't require post-construction BMPs. So there's a lot of these. Some of them are straightforward, like you would think, pothole filling, tree brush removal, repair of existing things like signs and curb and sidewalk. But then they get a little bigger. And you have to think about whether or not your project might be applicable to a routine maintenance. So culvert repair and replacement, you think, yeah, pipe replacement, that makes sense. But some of these culverts are really deep, 40 feet down, and a 6-foot diameter culvert where you have to cut out a ton of area. Linear grading, berm repair, and ditch clean out, that sounds reasonable, but sometimes you can do that for miles and have a really big disturbance. Bridge repair and replacement. So I can replace a bridge as long as my EDA is less than 5 acres and not get an NOI. Landslide repairs. So if that's kind of a safety thing, a lot of times if the hillside comes down, you have to fix it. So if you're just doing landslide repairs, you don't necessarily need an NOI. And these are for smaller projects, 5 acres or less. If you're bigger than 5 acres, you have some other considerations. Unpaved or gravel roadway or shoulder maintenance. So if you're repairing your shoulder, you can get away with not getting NOI. And this is another big one, full depth pavement repair replace. So this is more like if your big box store is redoing their whole parking lots, they don't need an NOI if they're less than 5 acres. Same thing if you're repaving all the way down to soil your whole roadway. If you're less than 5 acres, you don't need to get an NOI. So this has a lot of potential application in your highly developed roadway projects. So in the middle of a city, you might have a big roadway or a roadway project that goes a few blocks that is sidewalk to curb to pavement to curb to sidewalk. And so you could do full depth pavement repair there, and from an Ohio EPA standpoint, not need construction general permit coverage and not need post-construction BMPs. You might have some local requirements, but there's a lot going on there. So like this is a picture of a culvert replacement that looks like an awful big construction project, but the EDA is less than 5 acres and they're not changing the hydraulics to the pipe. So this type of construction project does not need construction general permit coverage, which is surprising to some who are not used to looking at, who would see a giant hole in the ground and say, whoa, you need permit coverage. And you could say, well, we actually don't because of this allowance for routine maintenance projects that Ohio EPA has. This is another type of project you might think, wow, there looks like a lot's going on there. If this disturbance is less than 5 acres and it's just a roadway full depth pavement replacement, they might not need permit coverage, let alone post-construction BMPs, as long as the disturbance is less than 5 acres. So these are kind of important considerations that a reviewer on a local side, for a city or county might go out and say, whoa, there's all this construction going on and they never told me about it. They never got permit coverage. There might be some local hoops to jump through, but from a state standpoint, they might not need permit coverage to even, they don't need permission from Ohio EPA to let it rain on their site like they would at maybe another site. All right, so that's routine maintenance. Next, we'll get into these straight projects. So utility fence, guardrail, and noise wall. This is really, ODOT does a lot of noise wall, so this comes up a lot. But if all of the project is associated with a new fence or guardrail or noise wall or utility line, you still need an NOI, a coverage and a construction general permit if the disturbance is over an acre, equal to or over an acre. But you don't need a post-construction BMP, and that's something that was written into the permit. It's written into the L&D. The permit has slightly vaguer language about linear utilities not needing to meet the conditions of the post-construction part, but we really specified what it means for ODOT in the L&D here. So basically, if you're building a giant fence or utility line or noise wall, you don't need a post-construction BMP, which makes sense because a lot of times these things might be big, might have big disturbance where you want the temporary erosion sediment controls, but they might be less than a foot wide. And it's hard to, and they might separate the flow too. So it's hard to get BMPs to treat, like less than a foot. And some of these might, fence doesn't really do anything. So there's a lot of relatively large, maybe expensive projects that don't need post-construction BMPs here. All right, so we made through the first two, routine maintenance and linear utility jobs or fence jobs. So what happens when we do need a post-construction BMP? So if we have the disturbance equal to or greater than an acre, and then ODOT really cares. We don't care about 2 acres or 5 acres or too much of that stuff. We really care about how much new impervious area and new right-of-way there is. So that's our second number we really care about. What's the disturbance, which we call earth disturbed area, and then how much new area are we paving in area we didn't previously own. So if we are paving less than an acre in new permanent right-of-way, or discharging to a big stream, which is a 4th order stream or a stream with 100 square miles or more, ODOT only needs to provide quality treatment. So this is the key difference between transportation and site development. We have this allowance that says only quality treatment, which our quality BMPs, our only quality BMPs are manufactured systems, which are like hydrodynamic separators, vegetative biofilters, and vegetative filter strips. So these 3 BMPs are not standard BMPs on site development that are allowed in Table 4A and 4B in the Ohio EPA's construction general permit. However, all this language about big streams, about less than 1 acre of new impervious area, it's all straight from the construction general permit. But we make it a little more explicit in the L&D in saying for roadway projects where less than 1 acre of new impervious area, new permanent right-of-ways occurring, you can just go straight to these BMPs if you want. The other BMPs are still an option. And these three BMPs I'm going to spend some time talking about because those are the 3 main transportation-specific BMPs that you might see go in on roadway jobs that you don't see very much on typical site development. And then if you have more than an acre of EDA and more than equal to or more than an acre of new impervious area, new permanent right-of-way, then ODOT and roadway projects get pushed into quality and quantity BMPs, which is getting the TSS down and controlling the flow to the stream a little bit. And that's where we get into BMPs that look just like Ohio EPA's 4A and 4B BMPs, detention basin, retention, bioretention, so all that fun stuff. Or a treatment train of quality and quantity. And that's kind of like underground detention and a manufactured system, hydrodynamic separator, or some other options, which I'll get in a little bit. So when a transportation project adds a bunch of new impervious area in the new area that's being acquired, they get pushed into the same BMP requirements that your site might have. But this doesn't happen that often. There aren't a whole lot of brand new roads being built. But when we do a big interchange project, or when there are new roads being built, a lot of times you'll run into needing a detention basin or bioretention cell. Those would be the two most common of these types of BMPs that you'd see on a roadway project. All right, so that's an overview of the regs. That's why the rules are different, and that's how it's written in. There's a lot there, but that's how that's going on. So as far as our ODOT BMPs, we'll get into them. And I'm going to really breeze over detention basin, bioretention cell, and infiltration trench, because those are kind of site development. I'm going to spend some time on vegetative filter strips, vegetative biofilters, and manufactured systems, and stream grade control, which a lot of people don't know about, but it exists. So I'm going to do the third poll question here in a second, so prepare yourselves. Our vegetated filter strip is ODOT's cheapest and easiest BMP, and it is effectively a grass slope, which seems like it's cheap and easy, because it is cheap and easy, but it really does a lot for water quality. They perform surprisingly well. We've done some studies, and a lot of water goes away, a lot of water infiltrates, and a lot of TSS goes away. So Dave, I can't remember if we're on the third or fourth. I think we're on the third poll question. The third poll question is, what is ODOT's cheapest and easiest post-construction BMP? So these provide quality only. I'm done with the poll question. You can answer it there if you want. These provide quality only, so they don't really slow down the water to protect against hydromodification in the streams. But ODOT owns a lot of these. So these work. I'm going to use my animation, which I made like 5, 6, 7 years ago, but they're still functional and how they work. So basically, it's a grass side slope, and when it rains, relatively dirtier water goes off and goes actually physically filtering through the blades of grass. So there's nothing magic happening. The grass acts like a strainer to slow down and to filter out the pollution. And we're going to call pollution happy little orange sediment particles. So when those flow through the grass, sheet flow through the grass, so not concentrated flow, but sheet flow. You got a few feet of pavement, 20, 30 feet of pavement going through 15 to 25 feet of grass. Those sediment particles will get physically stuck behind the blades of grass and kind of incorporate it into the soil. And the water that comes, there's a little bit of infiltration that goes down, but the water that comes down into the ditch or wherever it's going next is cleaner than the water that came off the road. So you have, instead of angry orange water, you have happy blue water going down. So vegetative filter strips are nothing magic, but they need grass to work as a strainer. They need nice thick grass, at least 70% coverage grass, to clean that water on the way down. So if you were thinking about incorporating these, or if you're looking at these, they're pretty much always 15 to 25 feet wide. They're always 3 to 1 or shallower, or 6 to 1 or flatter, depending on how much area. It kind of changes from either 3 to 1 or 6 to 1, depending on how much pavement's draining to it. And generally on roadway projects, if you get steeper than 3 to 1, you're looking at a guardrail. So these things generally are not behind guardrail. They're obviously not curbed because it's got a sheet flow into them. So on your roadway projects, you're looking at long grassy area that doesn't go to, has 15 or 25 feet before it goes into a ditch, and it's got a sheet flow off the road. So some cities have trouble fitting these in due to all the curved roads. ODOT has a ton of area that meets this criteria, where the highway, the interstate, the road goes off into a grassy area and goes into the ditch, which is really what we're looking for in the big picture of post-construction BMPs, LID, low impact development. You want to give water a chance from hitting the developed area to go into the grassy area and have a chance to infiltrate. So that's how that works. So, and the treatment credit is equal to the area of the road that drains to it and the area of the filter strip itself. So it's like if the 25-foot filter strip's on the north side and the road drains through it. You get credit for that whole area. And this is another weird thing that you have to get into the weeds a little bit, but ODOT does BMPs based on acres treated area. Ohio EPA does BMPs based on water quality volume. There's a lot of good reasons that both do it both ways, but if you're getting into the weeds, you're not looking at water quality volume as much for ODOT BMPs. You're looking at acres treated, and then it's just got to meet these criteria, which simplifies a lot of transportation projects. But it can be confusing for people who go back and forth between that detention basin at that new gas station and a roadway BMP to go back between water quality volume and acres. But so acres are what matter here. So on a set of plans, you wouldn't really see too much. Hopefully it would call out the BMP in some part of the plans, but you're basically just going to see some topsoil and some slope erosion protection, which is just that green mat on a set of plans. So which is why it's relatively inexpensive. The topsoil just helps for the grass establishment and a little bit of additional infiltration. And the slope erosion control mat it just helps with the grass establishment, keeps the grass in place. And then from a performance standpoint, there's got to be at least 70% vegetative cover and no erosion, no gullies or rills. And that's how that works. So ODOT probably has 700 or 800 of these, and most of them perform pretty well. You wouldn't know they were in the field because they look like every other slope, but they do a lot to treat the water coming off the roads. We also have these narrow vegetative filter strips, which you should really consider if you're doing bike paths or sidewalks. So if all the EDA is associated with some path, some bike path or sidewalk, and we're not talking about a roadway project, you can get away with these BMPs. You can use these BMPs, which make a lot of sense. If you have a 4-foot sidewalk, you don't want to be putting in a bioretention cell or a detention basin when the 4 feet of grass next to it's probably doing all the work. And that's an important thing. And it's important to know where you are. I know I think in like City of Columbus, it's I think 2,000 square feet of new impervious area drives the need for detention, like restricting the 100-year post-development peak flow rate to the 10-year pre-development peak flow rate. Well, 2,000 square feet is like less than a block of sidewalk. So you can get into some complicated post-construction BMPs that really drive up the cost when maybe the grass right next to the sidewalk is plenty. So we've talked this through with Ohio EPA. We think this is a really good option for your bike path jobs, especially if you have a new bike path going through a park. That's all new impervious area. That could drive up. You'd end up putting like a detention basin or bioretention cell right next to a forest, which doesn't make a whole lot of sense. So take a look at this if you're doing any of those path jobs at ODOT's narrow vegetative filter strips. And the requirement here is just that it doesn't have to be 15 or 25 feet. It just has to be the grass just has to be as wide as the pavement draining to it. So if you have a 10-foot bike path crowned in the middle with 5 feet on each side, you just need 5 foot of grass on each side, which a lot of times happens anyway on these paths. So it's built into the design. So it's an option. Vegetative biofilter is ODOT's most popular BMP. It's a little more difficult than the vegetative filter strips, but I'll explain it. Let's do the fourth and last poll question so I can be done talking about that. So what is ODOT's most popular post-construction BMP? And vegetative biofilters is named to sound fancy, but it is a grass ditch. It's a flat bottom grass ditch. So just keep that in mind. It sounds like bioretention cell. Some people get vegetative biofilter and bioretention cell confused, but it's a grass ditch. Just like a vegetative filter strip is a grass side slope, a vegetative biofilter is a grass ditch. And this only treats quality, so it doesn't protect the stream from hydromodification, but it does knock down the pollution a lot. So this works in the same manner as the vegetative filter strip, except the ditch is too close to the road, so you can't count on the 15 to 25 feet off the roadway. So you count on flat sheet flow through the bottom of the ditch. So the sediment particles come off the road, and then since you don't have enough space on the side of the roadway, you count on the sediment particles getting stuck in the flat bottom ditch. So this is a little trickier for BMP because flow wants to concentrate in ditches, and vegetative biofilters are meant to keep flow spread out and flat along the part of your the flat bottom part of your trapezoidal ditch. So generally these are at least 4 feet wide, so you can't have a 2 foot wide vegetative biofilter because that ends up just looking like a V ditch anyway. So they're generally 4 to 10 feet wide. Once you get much above 8, 10 feet, just space becomes a limit. Most projects don't have enough space to make 15-foot wide ditches. They are supposed to receive unconcentrated flow along the slopes. That's another thing. These are not good for curved roads. And that's because ODOT doesn't have any time of concentration requirements for vegetative biofilters. Other states have grass ditches, but they make you keep water flowing through that ditch for 9 or 10 minutes, which means your ditch always has to be 300 to 500 feet downstream of where the water comes from, which is awful hard. So by only allowing them on uncurbed roads where the grass sheet flows off the road, you take advantage of that extra filtering on the side and the slow of the water. And then we don't have those time and concentration requirements that other states might have. So generally, you look at these after you've figured out the vegetative filter strips don't work, and you're generally seeing if you can make your 2-foot ditch into a 4-foot, 5-foot, 6-foot ditch. We use Manning's equation to figure this out, just to figure out the depth and velocity. But basically, we use math, hydraulic math, and at the water quality flow, we keep the depth of water less than 4 inches and the speed of water less than 1 foot per second, which keeps the grass standing up and keeps the water going through the grass, which keeps that strainer function working. As soon as you get quick grass or quick flow or short grass, or it can fold down and not do that same straining. So that's what we're counting on there. We add topsoil and ditch erosion protection to these BMPs, and those are generally shown on the plans. These BMPs are supposed to have good grass coverage, minimum 70%, no erosion or concentrated flow, a flat bottom ditch. And every now and then you have to get in and remove trash and sediment, which makes sense because these things are BMPs, they're supposed to collect trash and sediment. So every now and then you got to go in and remove them if a lot of trash and sediment is collected. And these are not maintenance free. You got to mow them and keep them nice. And you got to catch down cutting early. You're not supposed to mow them when they're wet. And after you do screw something up, you got to regrade it. So these ditches seem cheap and easy on the design side. And then when you get into actually maintaining them, they get a little more expensive because this kind of thing happens where you mow it when it's wet. The only real way to fix that to get a flat bottom grass ditch is to regrade, which is annoying because maintenance was being performed to mow it. And then you're doing more expensive maintenance to fix the maintenance you did. So these ditches are used a lot on transportation projects and do have some maintenance burden to them. They're not free. Now, some locals, I know ODOT owns something like 1,300 of these across the state, and local transportation projects get them also. I know these BMPs don't fit as cleanly into some local BMP tracking systems. So you might be tracking your bioretention cells and your detention basins, your retention basins, but some cities might not know that they own 40, 50 of these ditches, 100 of these ditches that are BMPs that they're responsible for maintaining in perpetuity. So that's a consideration as a local, that once you get these put in on your transportation project, you own them forever and you got to keep them looking nice. So they work great when they work great. All right, manufactured systems. This shows a picture of a hydrodynamic separator going in the ground. That's kind of what it looks like before it's installed. One of the circular units with a concrete or with a square vault around it. These work a bunch of different ways, but in general, dirtier water comes in, does some kind of, hydrodynamic implies spinning, but some kind of settling out, settles at the bottom, floatables settle at the top, and then some, I know there's a lot of things moving around there, relatively cleaner water comes out in a short period of time. So the flow in is the same as the flow out, right? Because water can't just disappear. So it's supposed to strain out or let settle out the sediment or the pollution relatively quickly. And these do a good job in their intended purposes. And ODOT only owns about 80, 85 of these, but I know a lot of locals, a lot of cities and counties own a lot more of them. So there's plenty of these out there. They're relatively straightforward and they fit in more curved roadways where you don't have any other options. But you have to watch out for utilities. You have to watch out for deep pipes because you got to get in there and vac that thing out. So can't send it deeper than a vac truck can go. In ODOT's world, we don't approve any big ones, which big is bigger than 6 CFS. And a 6 CFS unit's like bigger than 12-foot diameter, 10, 12-foot diameter. So these would be big. And generally, we try to site them outside of the roadway so that you don't have to close down lanes of traffic when you're maintaining them once a year, things like that. And they should be vacked at least every 12 months, and you need access to them. So that's the big thing here. These are really, really easy for your consultant that you're paying to put into a set of plans, and sometimes a little trickier to maintain, that you have to get down and vac every year. So you want to make sure you know what you're buying if this goes into your project. They can do a lot. They can remove a lot of pollution, a lot of trash, a lot of oil and grease. They have a significant value. But you just got to know that once you buy these, you're vacuuming them out forever. All right, this is an extended detention basin. I'm going to crunch through this pretty quickly. Also, everyone hopefully knows they can put questions in the chat. I think there's a bunch of things there, so I'm going to try to hurry up. Anyway, detention basins. This is an animation for detention basins, but generally, detention basins just work by the same type of settling, just over longer periods of time. So ODOT detention basins look like other detention basins. We just have to be careful that cars can't flip over in them. So we have a few extra safety requirements. But that's what sedimentation looks like in a detention basin. So nothing revolutionary here. It's just a detention basin. Go to the next one, bioretention cells. So bioretention cells look a lot like, but ODOT does them in a linear way. So imagine there's a bioretention cell next to a road, and we actually own a lot of these, more than 40 of them along roadways. A bunch of different projects have them in, and they work great. So relatively dirtier water comes off the road and is held back by some kind of something that holds back water, a dike, a weir, catch basin, something. And that relatively dirtier water, the happy little pollution particles, come and they settle in the top inch or two of the soil. That brown box at the bottom is some high infiltration soil. When I say high, I mean like 1 to 4 inches per hour, not 100 inches per hour. And then it goes through an underdrain and goes away. So these fit in ODOT's world, almost any place that we have ditches on transportation projects, you can fit these bioretention cells. So a lot of times if we get pushed into that quality and quantity BMP world, we end up, these bioretention cells are a good option because they don't really take up as much right of way, and there's never more than a foot of ponding. So from a safety standpoint, they can be significantly safer than a detention basin that might have a few feet of ponding that you wouldn't want a car going into. You don't want a car going in this either, but it's significantly safer. They can fit in a lot of times in interchanges and intersections, more like a site development, or in a linear area. This bioretention cell you can barely see here on the right side is just that thicker grass right off the road. So it's a real small one, but they fit in a lot of places. And they're pretty easy to get a rule of thumb on how big they are, because generally they're 5% of the impervious area is how big your bioretention cells are. So they're not small, but 5% of your roadway area might be, only 2 feet, 3 feet wide along your whole roadway. So then it really is just like a ditch where you dig out and put your bioretention, your sandy soil in, and they can fit in a lot of places. Also, ODOT's done a lot of work to try to keep these as safe as possible. For our water retention, our water quality dike, we don't allow slopes bigger than 6 to 1. So these are big. They might be like 10, 14 feet wide, because you're trying to get up a foot by going up 6 to 1 and down 6 to 1. So 12 feet at the minimum, and a lot of times they go to 14 feet, because we don't allow more than 12 inches of ponding next to the road, or for bioretention cells in general. So if you're doing this along a roadway, ODOT's got a lot of plan insert sheets, a lot of CAD figured out for you. You can use a lot of that, and we see that used sometimes. Also, most bioretention cells are that deep, 40, 45 inches or whatever. You can elbow them up. I know that animation's kind of crude, but you can elbow them up to 24 inches, only 24 inches deep, which means if you have any kind of catch basin, it's already going to be down 30 inches plus due to, just where pipes are put due to freeze level. So if you can go up 24 inches, any place, if you have any kind of catch basin in the field, you can outlet a bioretention cell to it, which makes them very, they fit in a lot of places. There's some places up in Northwest Ohio where it's ditch to ditch to ditch, where it's all flat, where these might not work, but in a lot of places they do fit. Infiltration trench, I'm not going to go into. The key thing for infiltration trenches is a lot of the sediment removal happens in the pretreatment. So you need to have space for pretreatments, and ODOT has a very few of these, and they don't work great. You need A or B soils. I don't think too many transportation. I know Franklin County owns a few. They work fine, I guess. But we just don't have too many A and B soils in Ohio. Almost all the soils are C and D. So not a whole lot of infiltration trenches. I think City of Columbus has some around COSI and and Franklin County owns some out on Roberts Road, but really not too many of these in Ohio. Stream grade control. This is the secret BMP that's in our L&D. It's not secret at all, but you can get quantity treatment, what we call quantity treatment in ODOT's world for stream grade control, which is just a concrete, you can see the concrete at the end of that pipe. It basically is a grade check in a stream in the waters of the US. So we really don't own too many of these and people don't use them too much, but on bigger roadway projects, if you're crossing a stream, you can put one of these stream grade controls in, a grade check in, and pair it with a vegetated filter strip or vegetated biofilter. So a relatively inexpensive BMP in the grass and a culvert grade check, and that gives you quality and quantity treatment, which gives you basically equivalent to a detention basin for the quality and quantity treatment. So even in those instances where you get pushed into a bigger, more expensive BMP on a roadway project, there's sometimes options to do a treatment train for quality and quantity separately, and that would be either underground detention or the stream grade control BMPs, which not too many people know about or use. ODOT uses them sometimes, but they don't really go in the field too often. But it exists if you're interested in it. All right, so I tried to rush through that because I see we got some comments and I want to make sure we have time for questions. Alternative BMP options, so I'm just going to get into these quickly. The big one is that in the July 2022 updates, ODOT will be incorporating the amended vegetated filter strip BMP, which includes basically, it's like a soil amendment to the top 6 inches of the soil, and you get quality and quantity credit for it, which is a pretty big deal for a lot of reasons. It means we can get quantity treatments off of roadways without a ton of new right-of-way, which is big. And it also means even in ultra-urban areas where there is no space for this type of BMP, you might be able to mitigate with this BMP, meaning go a mile or half mile away where you do have this type of site along your roadway and amend the filter strip to get quantity control instead of putting in an underground vault. So ODOT doesn't ever want to build underground vaults. We don't need to underground detention in ultra-urban areas. So if we can go right next door and do some mitigation, it's a good option for us. So all this BMP is ripping the soil with a ripper about 12 inches, which is different. There's not a lot of rippers on construction sites. The contractor has to go rent one, but it's not that big of a deal. And then you incorporate some sand and compost, you rototill it in. And again, a lot of rotary contractors don't have a rototiller, but it's an attachment they can put on the back of a tractor. It's not that big of a deal. And then we actually compact it a little, which seems silly for a BMP to compact, but you got to be safe next to the roadway. You can't have it being too loose. And then you put some seed and compost on it, and you get some treatment credit. So this is also weird because we're basically treating it like an infiltration trench from a credit standpoint, but we know it doesn't work as well as an infiltration trench. So there's going to be some slightly complicated ratio from an area standpoint. We're going to give 45% credit for the pavement that drains to it and 100% credit for the amended area. So that just means if your project would have had to treat 5 acres, now you got to provide like 7.5 acres of this thing to meet the treatment requirement. So we'll have examples in the July update to the L&D. But this is coming and this is a big deal. This should save money on the biggest, hardest to treat projects. And this is a lot like Ohio EPA's runoff reduction credits for amended sheet flow areas, except it's way less restrictive. Ohio EPA's runoff reduction credits require a minimum width of 35 to 50 feet to get credit for those types of BMPs, which make them not real practical on most sites. ODOT's not going to have that. We're going to have no minimum. I think the minimum is 4 feet, which is more of a construction minimum than a water quality minimum. So on roadway projects, these will be very useful for quantity and quality treatment. So that's coming down. The other thing which I talked about briefly is this offsite mitigation. So offsite mitigation really is not used very often. ODOT uses it sometimes, but you got to demonstrate that that all your available BMPs are not feasible. You're supposed to work in the same watershed. It's called Hydrologic Unit Code, or HUC 12 watershed, which basically means it's within 2 to 5 miles, kind of. All the HUC watersheds are available online on ODOT's website or other places to see those. And then you have to provide 1.5 times as much credit as you would have otherwise provided. So in ODOT's world, that's like 1.5 times as many acres. In Ohio EPA's world, that's 1.5 times as many water quality volume gallons at the point of retrofit. and you got to maintain it forever. And Ohio EPA has to approve it on a case-by-case basis. So Ohio EPA has always played very nice with ODOT in these few offsite mitigation proposals we've given to them. But it does take some coordination, and really the biggest hurdle on this is a lot of times you'll scope a project and include a budget for BMPs, but you probably didn't include a budget for your designer to look at BMPs on your site and a different site and build them on a different site. So it can be cost prohibitive. It's why it's important to kind of look at BMPs early, which you should on a project. But especially on roadway projects, if your county or city is doing a roadway project and they're really stuck and they can look a mile down the road or a quarter mile down the road and there's all this space, you should really look into building 1.5 times as much treatment down the road as opposed to building something big and expensive just because it happens to be at your site. So this is really a don't make bad decisions about building expensive things on your road type of option. So this is just an example we did in Toledo many years ago where the this is a long roadway project split into 3 projects. So the 3 different NOIs, 3 different construction general permit coverages, but the bottom part of I-75 here was completely constrained, retaining wall to interstate to retaining wall. So there was no space for BMPs. So we added extra BMPs on the middle and north, the green and purple projects to mitigate the other BMPs missed. And it was, it took a little bit extra coordinating with the project, definitely on the design side, but from a cost standpoint, it made perfect sense. And from a water quality standpoint, it made perfect sense as opposed to building something big and expensive that no one wanted to own under the interstate. So it works when it works. You just have to put some effort into it. All right. Tried to finish early-ish. It's 11:51. So that was a lot. And I know I spoke quickly to try to get through all that stuff, but that's big picture overview of the transportation BMPs and the reasons they exist and the regs and all that stuff. So if anyone has any questions,
I think there were a few questions for you, John.
Yeah.
One of them was about roadway salts on some of the roadside BMPs. Do you see any adverse impacts from that?
Roadway salt? No, we don't. So we do put down a lot of salt. We know there's a lot of salt out there. There are places where our grass will die, probably more so from like compaction at an intersection where a whole big intersection goes into one area and all the salt is concentrated. But along linear applications where you just have the normal plowing and salting, it's normally not a problem. It's diffuse enough to not kill the grass. And there's not enough compaction in our bioretention cells when it's spread out. But there are areas right at an intersection where they salt extra heavy and they have to plow to one part of the grass that can kill the grass. Those areas can get oversalted and killed. So I've had one BMP that I know of out of ODOT's 2,400 BMPs that is not functioning due to salt. So it is not a big problem for ODOT. And that was one of those instances where it was a big paved intersection where everything always got plowed to one spot and the grass just couldn't survive.
And the other question was, has ODOT ever considered leaving the BMP grasses taller or unmowed to promote slower velocities and avoid the maintenance issues you discussed?
Yeah, so there's some options there. So ODOT only mows most roadways, most filter strips 2 or 3 times a year. So it's not a ton. You have to mow it at least once a year to prevent woody vegetation from going. So we need it to stay grass. We don't want it to be shrubs because forbs or stalky plants don't provide the same filtering. If there's one root, one stalk where there would have been 300 blades of grass, it's not doing the same filtering. So you got to mow it at least once a year. And we generally mow it twice a year for safety and aesthetics. On the back side of the ditches or way down the slope, we only mow once a year now in a lot of places. But in order to maintain 70% minimum grass coverage, 2 to 3 times a year is really the minimum you can go for mowing it. Otherwise, it turns into something else that's not grass.
So I've got another question here. Prior to January 2020, on the ODOT NOI acreage calculation form in the L&D Volume 2, we were instructed to list the EDA on the NOI for projects with an estimated NOI EDA of 1 or more acres, but less than 4.9 acres, use 4.9 acres. Why was the original practice, why was it removed?
Yeah. That's way in the weeds. So I don't know if anyone's gonna get here, but I have that answer. So we used to just say anything that was above 1 acre and less than 5 acres, just put 4.9 acres because it basically gave the permit more flexibility to tear up the ground. And we were worried that, you know, if we said 3 acres and we actually disturbed 3.5 acres, maybe it would be a problem. So we've gotten better at estimating the disturbance. And it used to be that anything 5 acres or less was the same permit cost. The cost of the NOI was the same, whether you did 1.3 acres or 4.9 acres. So that has changed also. Now I think it's 5.99 acres before the cost goes up. So the cost of an NOI is acre dependent above 6 acres. So basically the 4.9 rule just didn't make sense anymore. And we were having more and more projects that were just putting 4.9 without really looking at their EDA. So we wanted to know what the true EDA was, and we wanted to track that more closely, especially when it got into these routine maintenance type projects or these projects that were smaller. So it allows ODOT to better assess what the designer's doing during a review process. But very originally, meaning like 10 plus years ago, it was a permit cost issue where it was like, hey, you pay for 1, you pay for 4.9 acres, and it just doesn't make sense anymore.
And I think there was another question there about using no-mow mixes.
Like no-mow grass mixes?
Correct.
Yeah, we are actually looking into that. It's not that easy. Everyone wants to have a perfect grass mix that solves your problems. So like airports have been using low growing turf grass for a long time, and it takes years to establish that monoculture of grass, years of mowing the right way, mowing at the right time, right kind of herbicides, you know, getting the grass to grow. So none of these grass seeds are go throw some seed out there, walk away and have your problem solved. It's kind of like growing a fancy plant. Generally, if you throw a bunch of grass seed out there, you'll get grass and weeds, and you mow it, it'll eventually be grass because that's what grows when you keep the weeds mowed down. If you wanted to try to get that low height turf grass stuff to grow, you got to put more on the capital side, put more on the initial maintenance side. I'm not saying it wouldn't work. I'm just saying it might not make sense from a cost benefit standpoint. It might, but it's not just a different seed mix you're buying.
I think there was an earlier question. I can't get to my chat box right at the moment, but it was regarding installation of BMPs on less than an acre. Do you frequently do that on ODOT projects and use other temporary or permanent controls on less than an acre projects?
Yeah, so we always do erosion sediment control, temporary BMPs on any disturbance, even when we don't have an NOI. So ODOT requires, silt fence and inlet protection, all that stuff on all projects that have disturbance, not just that get NOI. We don't almost never put a BMP in if we don't have permit coverage, so don't have a disturbance over 1 acre. A post-construction BMP, sorry. We always have temporary BMPs. We don't have post-construction BMPs generally, unless there's some local road and there's some local agreement or some, there's always a case. But generally, if we don't need the NOI, we're probably not putting in a post-construction BMP. We don't need permit coverage.
We got time for one last question. What is the main difference between filter strips and biofilters? Filter strips and biofilters.
Yeah, so vegetated biofilters are grass ditches. Filter strips are grass side slopes. They do the same thing. Treatment mechanism is the same. The ditches, the vegetated biofilters, are harder to maintain because water screws more things up there than it does on the side slope. But they also generally treat more area because you get credit for the foreslope and the back slope of your project. So people like the ditches because it's easier to meet your treatment requirements, but they can be difficult to maintain. So always do the vegetated filter strips first if you can.
All right. Thanks, John.
Yeah,
I
and feel
think
free to email me or call me with anything. If I missed anything on this, or if I missed your question, just shoot me an email, and I get back to you.
there was a lot of questions about some of the questions for the survey, so you might get emails.
Yeah.
personally.
So
See
so
if you
also
can-
just fill out whatever and hit submit. So apparently Ohio EPA wants to track attendance real time for some like operator CEUs. So that's not the same as in engineering PDHs. So excuse me. So you can still get your PDH even if you don't do that. If you get your certificate, you're good. I mean, I'm not approving it because Ohio doesn't do that, but generally you can.
Yeah, be sure to put something in the check boxes and submit that for us. With that, I think I'll move on here. Do want to recognize our sponsors for OSWA. If you'd like to become a sponsor, here's some of that information. We would encourage you to join and become sponsors for OSWA. It is available. Get involved. That's the other aspect. We appreciate your membership, but there's always more to do. This is all volunteer. Everybody that's on the board within the OSWA are volunteering, and we would welcome your participation in that as well. Some upcoming SWA or some stormwater events coming up. April 6th will be the next webinar, data-driven risk assessment. May 10th or May 11th through the 13th is the Ohio Stormwater Conference. The MS4 boot camp is done in conjunction with that. And you are, as members of OSWA, do get some benefits, some reduced costs with the boot camp because of that. And July 27th, using runoff reduction method, manage stormwater on development projects, Justin Reinhardt. I want to thank John again for a great presentation, and Dana with WAMO, you're always a big help. Thank you for your help as well. And with that, I will say thank you and so long till next time. Thanks again.